prove the Gauss law. We start by looking at the electric field line from a point charge. Okay. Assume that I have a positive point charge Q. Okay. We know from Coulomb's law that at a distance r, electric field E is equal to KQ over R squared, and time the unit vector R, where the unit vector R point outward from the point charge Q. Okay, just move a little bit. Move to be here. Okay. Now, if I put this charge inside a spherical surface, you can see that at any point on the the point charge Q is at the center of this spherical surface. So we can see that the unit vector R will perpendicular to the surface at any point on this spherical surface, which means that if I define the differential vector dA like this, we will have that dA is parallel to the vector R. So if I want to calculate the total electric flux that pass through the outside surface, the outer surface of this spherical surface, from the definition of the flux, it's equal to the integral over the closed surface of E dot dA. But you can see that since dA is parallel to the unit vector R, it means that R dot dA is equal to dA. Since the unit vector R, the magnitude of this unit vector R is 1, so R dot dA is a R dA cos 0, because the A is parallel to unit vector R. So we have that R dot dA is dA. So we have on this integral is equal to E dA. But on the spherical surface, you can see that the distance R is a constant, right? Because R is a radius. So if R is a constant, it means that the magnitude of the electric field is a constant too. So we can put this E out of the integral. So we have this equal to the E integral over the closed surface of dA. The integral of dA over the closed surface is the surface area of this spherical surface. So we have that this is EA, where A is the area of the spherical surface, which is equal to E times 4 pi r square. But from the Gauss law, from this, if I substitute the magnitude of the electric field, this is the magnitude of the electric field, to this equation, I will have that this is equal to KQ over 4 pi, okay, because r square, this r square cancel with this r square. But from the definition of K, we know that K is equal to 1 over 4 pi epsilon 0. It means that if I substitute K here, the electric constant, I will have, this is not over 4 pi, it's a KQ times 4 pi. Okay. It's a KQ times 4 pi, and if I substitute this K into this equation, I will have Q over epsilon. Okay, so it means that the flux, the total electric flux at the outer surface of the electric field from this point charge center at the center of this spherical surface is equal to Q over epsilon 0. Okay.